In this video, I'll show you how to shade curved surfaces with pen and ink using hatching and cross-hatching. In particular, I'll show you how to shade cones, cylinders, and spheres. In part 2 of this series, I showed you how to shade flat surfaces, and I showed you how perspective can help you to think about the direction of your hatching lines when you're shading a cube. Perspective can also help when you're shading a cone or a cylinder. This flat surface is a circle when you look at it straight on, but when you look at it from a different angle, it goes into perspective. A circle in perspective looks like an ellipse. An ellipse has two axes, a major axis that defines the widest part of the ellipse and a minor axis that defines the narrowest part. The minor axis is useful because it points towards the vanishing point of a cone or a cylinder. In fact, if you have an ellipse template that shows the major and minor axes, then you can use it to quickly and easily draw a cone. You can draw a line through the minor axis to define a vanishing point, and then draw lines from that vanishing point to the endpoints of the major axis. And if you have a smaller ellipse template, then you can also quickly and easily draw something that looks a lot like a cylinder in perspective by positioning its minor axis on that same line to the vanishing point, and positioning its major axis so that it fits between those two converging lines. This is good enough for shading practice, but it's not actually a perfect cylinder in perspective, and I'll try to show you why it's not, because I hope it will help you to think about the curvature of your hatching lines. The smaller ellipse at the back of this cylinder should not actually have the same shape as the larger ellipse at the front. It should be slightly wider. When you look at a circle straight on so that it looks flat, you're seeing it at 90 degrees. Your line of sight is perpendicular to the circle. But if you rotate it so that it looks like a straight line, you're seeing it at 0 degrees. The angle at which you see a circle in perspective is called the degree of the ellipse. So a 90-degree ellipse is a circle, a 0-degree ellipse is a straight line, and this ellipse is somewhere in between. It's a circle that you're seeing at about 35 degrees. When you look at a cylinder in perspective, you're seeing the circles at the front and the back of the cylinder at slightly different angles, and so they should actually be ellipses of slightly different degrees. The ellipse at the back should be slightly wider. That said, I think this method of drawing a cylinder is good enough for shading practice, since it's quick and easy to draw repeatedly. And if you draw a cylinder in two-point perspective, so the vertical lines don't converge, and if you draw the ends of the cylinder at equal distances from the horizon line, then actually you can use the same ellipse template for both ends of the cylinder because you're seeing them at the same angle, and so this cylinder is drawn correctly in perspective here. The top of the cylinder is above your eye level, above the horizon line, and the bottom is below your eye level, below the horizon line, and the center is at your eye level. So you're seeing it at 0 degrees, and it looks like a straight line. And if you could see the ellipses in between, they'd be wider than a straight line, but not as wide as the ellipses at the bottom or the top. So the ellipses in this cylinder that are farther away from you are wider. This ellipse at the front of the cylinder is a flat surface, and so you can shade it with straight lines, just as if you were shading the face of a cube. That's the easy part of shading a cylinder, the flat part. But here's the hard part. The curved part. It's hard for two reasons. The first reason is that it can look flat if you shade it using straight lines in the wrong direction. These straight lines do not follow the contours of the cylinder, and so they make it look flat. You can use straight lines if they're parallel to the long edges of the cylinder and in perspective so they converge at the same vanishing point, because these straight lines do follow the contours of the cylinder, because the cylinder is flat in this direction. But then you have to solve the gradient problem that I showed you in part 2 of this series, where the surface gets darker as it approaches the vanishing point unless you vary the line weight. And this is obvious if you try to shade a cone with straight lines in perspective, as you can see here. Instead of straight lines, you can use curved lines that follow the contours of the cylinder. These are called cross-contour lines. You can think of these lines as rubber bands that wrap around the cylinder. These rubber bands are circles, and so they look like ellipses when seen in perspective. If you want your hatching lines to look like this, then your hatching lines should be ellipses. Well, actually, your hatching lines should be sections of ellipses, the sections that you can see on this side of the cylinder. And actually, you're seeing each of these ellipses at a slightly different angle. In theory, then, your hatching lines should be wider. They should curve more at the back of the cylinder than they do at the front. In practice, though, this is really hard to do, and I'm happy if I can get my hatching lines to look relatively evenly spaced and to look like they curve around the form, which is hard enough. It's really hard to hatch using curved lines. It's hard even to draw pencil guidelines for curved hatching lines, even when using an ellipse template. Even if I ignore the problem that the degree of the ellipse should change along the length of the cylinder, I still have the problem that the height should change too as the cylinder converges towards the vanishing point. I don't have enough of these templates in just the right sizes to make evenly spaced ellipses 1/8 of an inch apart along the length of the cylinder, and I doubt that anyone else does either. It would take too many templates just for the this one cylinder. And you can't just use a smaller part of a larger ellipse template because the hatching lines will look like they stop at the edge of the cylinder. They should look like they continue to curve around the form. So you need to draw these lines freehand, and that takes a lot of practice. I haven't done it perfectly here, but I hope you get the idea. Ellipses are not the only kind of cross-contour lines. For example, you can hatch using spirals, like a barber pole, or you can hatch using ellipses that are not aligned with the ellipses at the front and the back of the cylinder. That's not a problem. They're still cross-contour lines. Cross-contour lines are just lines that conform to the surface of whatever you're drawing, as if they've been shrink-wrapped onto it. So they help your drawing to look three-dimensional. In theory, you could even say that these straight lines are cross-contour lines, but in practice people seem to mean curved lines when they talk about cross-contour lines. These straight lines are not cross-contour lines because they don't conform to the surface of the cylinder, but these straight lines technically are cross-contour lines because they do. You also need to think about whether a curved surface is convex or concave, because this will help you think about the direction of your hatching lines. These ellipses all curve in the same direction. They curve towards the vanishing point because this is a convex surface. But if you draw a pipe, which is just a hollow cylinder, then the ellipses on the inside of the pipe curve away from the vanishing point because the inside is concave and the outside is convex. Your hatching lines can also seem to change direction depending on the angle you're seeing them at. For example, if we go back to this cylinder, the ellipses above the horizon curve towards the top, and the ellipses below the horizon curve towards the bottom. And you don't see the flat surfaces at either the top or the bottom of the cylinder in this drawing. But if you draw a half pipe, which is just a half cylinder with no flat surfaces at the top or the bottom, then the ellipses curve in the opposite directions. The second reason that it's hard to shade a curved surface is that it reflects different amounts of light at different points, so you can't just pick a value from your value scale and use that value for the entirety of the curved surface. You need to make a gradient of different values at different points. This is a lot like the reflected light that I showed you in part 2 of this series, but it's harder because it often goes from light to light again, or dark to dark again, depending on where the light is coming from, and it's really hard to do when you're using curved hatching lines. Here I used the same fineliner pens as I used to make my value scales in part 1 of this series. I also drew guidelines from the vanishing point, so I had a sense of where to change from one value to another. In theory, I'm trying to show you the highlight, mid-tone, core shadow, and reflected light as different values. Here I tried to do the same thing using a dip pen with a flexible nib. This is a Gillette 303 nib, and I'm using it in a speedball oblique nib holder. This nib holder is new to me, and oblique nib holders like this are normally used for calligraphy, but I thought I'd try this out for drawing here, and I haven't quite gotten the hang of it yet, but I think I like it. I think this is probably the hardest thing to do in pen and ink drawing. Parallel curved lines with variable line weight. Obviously I haven't done it perfectly here, but I hope you get the idea. As I showed you before, you can also use straight lines in perspective, which are not as hard to draw as curved lines, but then you have to solve the gradient problem where the surface gets darker as it approaches the vanishing point. Or not. It might not look very bad if the cylinder doesn't converge very much. I don't think this looks bad. You can also use crosshatching. And if you're crosshatching, you can use some combination of ellipses in different orientations. Or if you're crosshatching and you're struggling to draw curved lines, then you can also try to use straight lines. And with enough layers of crosshatching, they may not seem to flatten the surface very much at all. You can use a circle template to draw the outline of a sphere in perspective. The outline of a sphere in perspective is a circle, not an ellipse. So it's easier to draw a sphere than a cylinder in perspective if you just have a circle template. If you think about a globe, you can try to make your hatching lines look like the equator and the other latitude lines, which are circles, and so they look like ellipses when seen in perspective. So this looks a lot like shading a cylinder, since your hatching lines are ellipses. If you orient your ellipses so that they're perpendicular to the direction of the light, then you can use different line weights for different ellipses to create your value gradient without having to use different line weights within each ellipse. Or you can try to make your hatching lines look not like latitude lines, but like longitude lines, which also look like ellipses when seen in perspective, but these longitude lines intersect at the north and south poles, unlike the latitude lines which don't intersect at all. So this doesn't really look a lot like shading a cylinder unless we go back to this example, in which the ellipse at the center looked like a straight line, since we were looking straight at it. Likewise, you can draw one of your hatching lines on your sphere as a straight line through the center, and you can draw the others as ellipses that are centered on that straight line, with wider degrees as you go farther away from the center. But because your hatching lines intersect at the poles, then you again have to solve the gradient problem. Here, the sphere gets darker as the hatching lines approach the pole because the lines get closer together, but the line weight doesn't vary. And if you want to solve that problem by varying your line weight, then I think it can work better if you orient your ellipses so that they're parallel to the direction of the light, which I did for this third sphere. And you may have to go back and forth with different pens of different line weights to try to get it to look right. But I think it's really hard to shade spheres using any of these methods, so try not to get too frustrated. Here are some other examples from my sketchbook. If you're crosshatching, you can use some combination of latitude and longitude lines. And if you're struggling to draw curved lines, then you can try to use straight lines, and they may not seem to flatten the surface very much with enough layers of crosshatching. So there are a lot of other ways to shade curved surfaces in pen and ink if you're struggling to draw long, curved lines that are perfectly parallel to one another. Straight lines can sometimes work, and so can short lines. But different kinds of lines create different kinds of texture. So you need to think about the kind of texture you want to create. You can even use scribbly lines. Personally, I think curved surfaces are really hard to shade because it's really easy to see every imperfection on such perfect geometric forms as cones, cylinders, and spheres. The good news is that it's harder to see every imperfection on organic forms, such as muscles and faces. So unless you're planning on drawing cars or spaceships or something with perfect geometric forms, your actual drawings will probably look a lot better than your practice exercises. But I think it's still worth practicing these geometric forms because they'll teach you to think carefully about the direction of your hatching lines. In part 4 of this series, I'll show you how to shade faces, which are not actually as hard as you might think if you know how to shade flat surfaces and curved surfaces as you do. Please like this video and subscribe to my channel for more videos about pen and ink. Thanks for watching.